Jupiter does have a rocky surface. Yes, you heard it right. But it is not completely made up of rocks. In fact, it is only up to 9% of rock and metal. And it means it ate a lot of planets in its youth. So let's get into the video. Jupiter is composed almost entirely of hydrogen and helium. But it also contains other heavier elements which astronomers call metals. Even though metals are a small component of Jupiter, their presence and distribution tell astronomers a lot. According to a new study, Jupiter's metal content and distribution means that the planet ate a lot of rocky planets in its youth. Ever since NASA's Juno spacecraft reached Jupiter in July 2016 and started gathering detailed data, it's been transforming our understanding of Jupiter's formation and evolution. One of the features of the mission is the gravity science instrument. It sends radio signals back and forth between Juno and the Deep Space Network on Earth. The process measures Jupiter's gravitational field and tells researchers more about the planet's composition. When Jupiter formed, it began by accreting rocky material. A period of rapid gas accretion from the solar nebula followed that, and after many millions of years, Jupiter became the behemoth, which of course it is today. But there is a significant question regarding the initial period of rocky accretion. Did it accrete larger masses of rocks like planets, or did it accrete pebble-sized material? Depending on the answer, Jupiter formed on different time scales. We are growing normal to gorgeous images of Jupiter, and of course, thanks to the Juno spacecraft and its main camera, the Juno cam. But what we see is only skin deep. All those spellbinding images of the clouds and storms are only the thin 50 kilometers of outermost layer of the planet's atmosphere. The key to Jupiter's formation and evolution is deeply buried in the planet's atmosphere, which is tens of thousands of kilometers deep. It is widely accepted that Jupiter is the oldest planet in our solar system. But scientists want to know how long it took to form. The researchers wanted to probe the metals in the planet's atmosphere using Juno's gravity science experiment. The presence and distribution of pebbles in the planet's atmosphere play a central role in understanding Jupiter's formation, and the gravity science experiment measured pebble dispersion throughout the atmosphere. Before the Juno and its gravity science experiment, there was no precise data on Jupiter's gravity harmonics. The researchers found that Jupiter's atmosphere is not as homogeneous as previously thought. More metals are near the planet's center than in the other layers. Altogether, the metals add up to between 11 and 30 Earth masses. With data in hand, the researchers constructed models of Jupiter's internal dynamics. There are two mechanisms for a gas giant like Jupiter to acquire metals during its formation, through the accretion of small pebbles or larger planets. Once a baby planet is big enough, it starts pushing out pebbles. The richness of metals inside Jupiter that we see now is impossible to achieve before that. So we can exclude the scenario with only pebbles as solids during Jupiter's formation. Planets are too big to be blocked, so they must have played a role there. The abundance of metals in Jupiter's interior decreases with distance from the center. That signifies a lack of evaporation in the planet's deep atmosphere, which scientists thought was present. The astronomers also say that Jupiter did not mix by evaporation after it formed, even when it was still young and hot. When the James Webb Space Telescope starts science operations, one of its tasks is measuring exoplanet atmospheres and determining their composition. So, what do you think? Comment down your opinions. And if you are new to this channel, consider subscribing for more such videos. Thanks for watching and see you in the next one.